This little video will take us through the revision questions of multiplying and dividing powers, and will also take us through the questions here that are based on power of 0. So question 1a is multiplying powers. Remember that the 6 and the 2 are our powers. Okay, and in class we've been saying that a power is always best friends with a base. So base power, and this term and this term have the extra dimension of a pronumeral. So we've been trying to make sure you know each part of the terms. For our questions, there will always be a power, and connected to the power is always the base. The base can be a letter, like it is in this question, or a number. For this question and these terms, it's a variable or a letter, and connected additionally is what we call a pronumeral. So for our index law 1, when it's multiplying powers, our rule is to keep the base and add the powers, so 2 plus 6. Then we must remember that with our pronumerals, it's like if we ignore the m squared, we have 4 left. So 4 multiplied by, if we ignore the base and the power, 5. So 4 multiplied by 5, we have to remember to multiply our pronumerals. If we ignore our base and our power, we have 4 multiplied by 5. Question B. Okay, again it has a pronumeral, a base and a power, divided by a pronumeral, a base and a power. So with our division, it's index law 2. Index law 2 tells us to keep the base and subtract the powers. 5 subtract 3 gives us y squared. And we must remember to divide, in this case, our pronumerals. Up here, obviously, we had to multiply our pronumerals to give us 20. Here we divide our pronumerals. So our answer is 3. 6 divided by 2 is 3. And then we had to follow the rule of keep the base and subtract the powers. This one is division. So again, we keep the base and subtract the powers as a starting point. We have 2 bases in these questions. We have a y base and a z base. So our y is 5, keep the base, subtract the powers for division. So 5 take away 3 is going to give us y to the power of 2, or y squared. Keep the base again and subtract the powers is going to give us z to the power of 4. Okay, here we have 36 as a pronumeral divided by 2. 36 divided by 2 gives us 18. Okay, just like 4 multiplied by 5 gave us 20, and 6 divided by 2 gave us 3. 36 divided by 2 gives us 18, and we just had to separate or do twice our keep the base, subtract the power rule. Okay, so they should be pretty easy for you by this point in time, Year 8s. I do hope you took the time to look at this really good YouTube clip. Remember, I did say that in your test, it's not just about knowing that anything to the power of 0 equals 1. It's in your test. Problem solving and reasoning type questions might ask you to explain or demonstrate or prove that anything to the power of 0 equals 1. So it's that deeper understanding of what is a pretty straightforward rule to remember. Okay, the rule itself is pretty straightforward to remember, but this YouTube clip shows you ways that you can prove or demonstrate or explain this rule. So take the time to look at that YouTube clip. Here are some questions. So A can be anything. A could have a value of 10 or it could have a value of 1,000. It doesn't matter because anything to the power of 0 equals 1. Alright, so it doesn't matter what the value of this variable is. Anything to the power of 0 but gives us 1. Okay, this question is a little bit more complicated to look at. We have z to the power of 0 and we have x to the power of 0. So it's kind of like we can cancel these out. Okay, I might bring this question down here. So it's really saying 12 multiplied by x to the power of 0 multiplied by y squared multiplied by z to the power of 0. Okay, so if we say 12 multiplied by 1, anything to the power of 0 gives us 1. Multiplied by y squared multiplied by anything to the power of 0 gives us 1. So hopefully now you can see that you can basically ignore these ones because anything multiplied by 1 isn't going to make a difference. Multiplying by 1 isn't going to change anything. So now you can basically disregard those two parts of the expression because anything multiplied by 1 is going to not make a difference. The multiplying by 1 is not going to change the value. So what you can say we're left with is basically the 12 multiplied by the y squared, because we can ignore these times 1, and more simply it can be written as 12y squared. Okay, so this one equals 12y squared because of this thinking. Okay, this one is really 2 multiplied by x to the power of 0 and y squared. Okay, so it's 2 multiplied by 1 multiplied by y in there squared. So you can ignore this one again. Okay, and what you're basically left with, or what you are left with if you ignore that one there, is you're left with 2 multiplied by y squared. 2 multiplied by y squared. Okay, so just because you see a power of 0 in a question, it doesn't mean the answer is going to be 1. It means that part, okay, is a value of 1, and as you can see the questions might have other factors or, you know, bits and pieces happening around it. This one is lovely. Whatever is inside here is like a big parcel, a big packet. 5 times b, it doesn't matter what that is as a value because it's all being put to the power of 0, so that gives us 1. Okay, same as here we have brackets, so whatever's in the brackets like a big parcel, and the whole parcel is to the power of 0, so it doesn't matter what's in that parcel, it has a value of 1 as well because it's a whole parcel being put to the power of 0. Okay, similar here, we have a whole parcel being put to the power of 0, so that part of it equals 1. Then we have 4x 0, and it's always times. If there's no operation written there, it's always multiply. So this here equals 1 as well, doesn't it? X to the power of 0, so we can cross that out. So we've kind of crossed this whole part out here because the whole parcel in there was put to the power of 0, so it equaled 1. This here gave us 1. So all we have left here is 4 times 1. It's just 4.